So with me today is Keith Pennachio from SQUAN, a great telecommunications company. Keith, welcome.
Thank you.
So tell us a little bit about what you do and about SQUAN.
So, as the Executive Vice President for SQUAN, my responsibility is really looking at the telecom landscape to best understand some of the trends in the industry, look at some of our acquisition targets, and see how they fit within the core that is SQUAN, which is focused primarily on wireless network infrastructure.
Okay, and now you've been in this business for over 2 decades, right?
Yes.
What is the secret for building a high-performance team, especially that has the technical expertise for this industry?
The key is finding people that are going to take ownership of their roles. Good project managers, good people who are technically proficient in design and construction, and really bringing them into your team and making them part of that team.
Now, these are people who are what, engineers or?
It's a mix. Yeah, it's a mix. We have several folks that are professional engineers, but we also have other folks that do technical installations for electronics. We have guys that climb towers, work on rooftops, install cable, as well as folks that sit at a desk and do computer-aided design using our AutoCAD software.
Now, let's talk about infrastructure, because this is a massive scale, something that everyone uses on a day-to-day. What are the challenges that SQUAN faces with that?
So some of the biggest challenges are the changes in technology, right? Everybody remembers that commercial with Ozzy Osbourne and how many bloody G's are there. What we find is that each transition from one technology to the next requires a new set of rules to deploy that technology. And as we look at macro networks that are mostly deployed today in the form of cell towers and rooftop installations, we see that a lot of the densification projects that are going on, focusing on the right-of-way and in-building solutions, is where Legacy SQUAN primarily focuses originally.
How do you keep up with that?
It's a lot of training. We partner with some very well-known electronics firms who provide support in the form of training for installation services of their devices in the network. So companies like Ericsson, Nokia, Samsung, others, we work with to ensure that our team is up to speed on some of the latest technology.
And you're primarily doing fiber optic and Wi-Fi?
Yeah, so it's a mix of wireless and wireline, we'll call it, right? So anything that has to do with fiber design, for backhaul, for front haul, for structured cabling in a facility, or wireless network construction. So we'll take the wireline component, marry it or couple it with the wireless component, and we'll have a fully operational dense network.
So you could be really a home provider as well as a large-scale provider?
So it's one of the key differentiators is that we're a services provider specifically around the infrastructure. We don't do a lot of in-home type work, but what we do is in businesses that are looking to get wireless technology in their building or high-speed fiber. Especially as the trends evolve and people are more dependent on their devices, we see that there's been an uptick in demand for higher speed services in the form of fiber and wireless.
Now, I think when people hear both fiber and Wi-Fi, they're always just thinking internet, but that's not just what you guys do. And not far from here is a 1 million square foot building from Canon's headquarters, and some of the technology there was more for two-way radio communication. Mm-hmm. I don't think people maybe really understand the challenges of wireless signals inside a structure that big. So what are the challenges? How do you overcome those challenges?
Mm-hmm. Well, those challenges are abundant today, not just with the Canon World headquarters, but to give you an example of some of the issues we face in a facility like that, is that once the fiber comes to the building, it's on a company like SQUAN to help with a robust design to do all the structured cabling, place the remotes, place the antennas that'll support a truly wireless environment. So we work with the building management to determine where best we could put our equipment and to locate in areas that are high traffic in order to offset some of the traffic that they're looking to manage within the facility.
Now, obviously, with a building like that was built from the ground up, So I would imagine that made it a lot easier. How do you really work with them in a pre-existing structure?
Pre-existing structures could be a little more challenging, especially as the technology advances. There's a lot of retrofitting that goes on, especially in a city like New York, where you have a lot of old building materials, granite, marble, where you're trying to be sensitive to the facade. There are solutions, though, that are manufactured to mask a lot of this equipment.
And with these challenges, I would imagine, especially with the upgrades in technology and keeping up with that, how do you upgrade this technology? Because there was a time where just even wiring the building those wires are obsolete. We're talking fiber. Fiber didn't exist, or it was just tremendously expensive at one point. So how do you kind of replace all of that?
Very carefully.
Yeah.
Yeah, no, it takes a lot of effort, and a lot of planning. Like I said, we work with the building management in most cases, or the building developer, to go and retrofit a lot of these installations. You point out, and this is a problem that's coming about for a lot of facilities that have older equipment. So companies will call SQUAN in to come in and help with a retrofit design. Meanwhile, all of the existing equipment has to be removed. So a lot of times we'll work toward coordinating the removal of that equipment and then just replace in the same conduit some of the newer technology, and then same locations, unless the design changes. If the design changes and the equipment that's being placed has a different coverage profile, we'll deal with that accordingly.
I'm thinking about two big challenges for you. One, Middle America, where getting the technology there to such a remote location must present some challenges. And then opposite, you have something like New York City, where you have all these different radio frequencies going around. Which is the worst challenge for you?
So for us, fortunately, that's not a big issue, because the frequency management is typically done by the radio frequency engineers that are employed by the network operators, or the folks that are looking to deploy a third-party network. There are ways to identify where that spectrum is propagating and work around it. But for us, most of the work we do is really placement of equipment post-design.
Okay. And with Wi-Fi signaling, are we into satellites, or are we just strictly regular?
So to be clear, it's not just Wi-Fi, right? Wi-Fi is certainly a component that we deal with, but mostly the radio network that we deploy today for companies like Verizon, T-Mobile, Sprint, employ their signal source to support the network within any one particular building, or just in the open environment. So it's not limited to Wi-Fi. We span the technology realm for all types of installations.
What are some of the big changes that you see coming?
Some of the biggest changes are densification, and densification of networks means that companies need to get closer to the user. New technologies like autonomously driving vehicles demands in building to get greater signal source that might be impeded by a LEED certified building that presents certain types of challenges. Getting the sites supported by backhaul and power closer to the user is probably the biggest challenge, and that translates into negotiations for new use rights, or working with jurisdictions on regulations that allow for the placement of antenna equipment.
And how do you keep up with the regulatory demands?
We play heavily with our partners, companies that are also looking for the same type of end solution, mostly on the network infrastructure ownership side. So companies that actually own the towers, or own the poles, or own the fiber are the ones that are really at the forefront. We are helping to advise them, given our experience with network deployment, to get to the point where they're able to, by right, get the equipment in there.
How challenging is that?
It's challenging. Yeah, it's
I would
really
imagine.
challenging. Yeah, especially when you deal in the public right-of-way, which is historically controlled by the utility companies. It's a challenge.
So give me an example of the diversity in the services that you offer.
So SQUAN, as I mentioned before, started off as a wireless consulting group. focused mostly on design build for the wireless space. In the time that I've been there, we've acquired 3 companies. We acquired a fiber construction company that also deals in copper construction outside plant. We also purchased an outside plant engineering firm, and we also purchased a small general contractor that helps support us in certain pockets throughout the South for all of our builds, actually.
Talk to me about some of your high-profile clients. And I know that we can't go into too much detail, but some of these are very interesting.
There are some limits on what we can disclose, but some of the more notable projects that you'll find on our website, we did some work at FedEx Field, Central Park, Madison Square Garden, and those were a wide variety of services, whether it was just some structured cabling or replacing equipment, or even in some cases disaster recovery.
Where does SQUAN primarily operate?
So we operate throughout the entire country. Most of our construction services focus on the stretch of territory between Washington, D.C., north to Boston, and pockets throughout the South. We also do a lot of engineering throughout the rest of the country. So our outside plant engineering and inside plant engineering services cover across the entire South from Florida all the way to California, pockets into the Great Lakes, and then back across through Ohio into New York State. And we're starting to do additional work here in the New York Metro for our engineering services.
And you mentioned disaster recovery. So I would imagine that's almost an entire different thing, because
It is.
you may have things could be damaged. I'm assuming that are outdated, and tell me about that.
So it happens frequently. You know, whenever hurricanes come through, or you have tidal shifts where you have extreme flooding, we get called frequently to go and either supply generator support, replace antenna equipment, replace radio equipment that might have been submerged, or high winds knocking antennas offline. There's a wide variety of issues that pop up for everybody when there's a natural disaster. So we're called frequently to come in and fix that.
So when you see something like Puerto Rico, like how would SQUAN handle something like that?
So SQUAN doesn't currently operate in Puerto Rico. However, the issues that Puerto Rico faced were plenty. You know, going down there and finding the appropriate remedy for replacing towers, resupporting towers, or reinforcing those towers, replacing antennas, getting power to these sites. Puerto Rico, because of its challenge with its electrical grid, had a lot of issues in getting power back on. I think it was only within the last couple of weeks that they were up to full power. Right. So Puerto Rico, even prior to that storm, was pretty heavily dependent on generator power throughout the island for pockets where they had issues in getting that power to the cell site. So backhaul is another issue. When fiber or copper service isn't available, a lot of times what these companies will do is they'll use microwave to get backhaul to those sites.
So it's interesting with the microwave technology. How does that work, and then work into your fiber technology?
So for us, it's just a tool in the toolbox, and more times than not, our network operator clients will determine what will be used. Now, wireless backhaul in many cases is cheaper to deploy because you're not dealing with trenching, you're not dealing with heavy construction in the right-of-way, road closures, anything that would require extreme amounts of effort to get the fiber into the ground. Microwave, even though it's a good option, some of the issues that you encounter are weather. So high winds with those dishes, which are more dependent than your traditional cell network antennas, that the dishes are typically larger and more susceptible to wind gusts, and sometimes will knock them out of alignment.
What are some of the big projects that you have coming up?
So right now, you know, we're working, as I mentioned before, we work with Verizon, T-Mobile, Sprint, AT&T, Charter, Altice. We've got a lot of work that is focusing in the direction of 5G. I think if you talk to different people, you'll probably get a different definition of what 5G actually is. However, I could tell you that, as the technology is updating, we're involved in the vast majority of those projects.
So when that technology gets updated, how much of the device or the infrastructure do you have to replace?
So the infrastructure needs significant upgrading. The device, as time goes by, 5G it goes beyond your handheld device, and now we're talking about Internet of Things applications, and we're talking about different node placement for use in a controlled environment where a building owner is trying to monitor their mechanicals, just to keep tabs on what's going on with utilities and such.
So take me through the step-by-step process. So someone calls and they need SQUAN, and we need your engineers to design something, and you're going to go into a big, let's say, condo complex or an office building. What's the process there?
So usually the first thing that happens is a developer is either aware of some of the issues with radio frequency in their facility, or they just have a solid technical understanding of what needs to happen in their building, and they want the latest and greatest technology. So we typically, SQUAN gets a call and says, hey, listen, I'm thinking about putting a distributed antenna system in my building. I'd like you to come down, take a look at my facility. We typically dispatch our technician with one of our program leads to walk the building and really take an overview assessment of what's going on in the facility. From there, we'll do a full-on analysis of the radio frequency characteristics for the building. And then what we'll do is we'll take that information back, work with the property owner or property management company to acquire the building drawings, take that information, feed it into our systems, and drum up a design that we typically present to the building owner or property manager, along with some estimates on what it would cost to actually build a facility like that. From there, that transitions into whether or not you have signal source from one of the carrier operators, network operators, and that's where we work with our relationships within each one of those network operators to determine where that funding comes to support the signal source. In some cases, on the enterprise side, what we're starting to see is that the building owners themselves are footing that bill, or at least paying for a substantial part of it, looking for another third party to come in and either support it with financing or looking for some other type of assistance from the network operator to get their signal source in that building.
So talk to me about the small cell solutions also.
So small cell solutions, as we're encountering today, SQUAN, because of the outside plant engineering work that we do as a result of our acquisitions, we're finding that using that expertise and lending it to the wireless side is giving us a leg up as we start to look at how do you get these small cells placed. And small cells, in a lot of cases, are being placed on wood poles or on light poles. If you go into the city, you'll start to see some of them, in addition to maybe closed-circuit cameras that'll be on intersections. But you'll start to see antenna equipment, and in some cases, you may even see some radio equipment approximately 10 feet off the ground or on the facades of some of the buildings.
And before we were talking, we mentioned DAS versus Wi-Fi. Explain that.
So distributed antenna systems are fed by a signal source that emanates from one of the network operators, whether it's AT&T, Sprint, Verizon, or T-Mobile. Wi-Fi is typically a setup that either you and I would go out to Best Buy, purchase the equipment, take a feed from our home provider in the form of fiber or copper, and feed that into your own Wi-Fi system, and then operate your network in your building or in your office or in your living room, where it may be. But signal source, as it relates to the RAN, the radio access networks, is something that is much more robust, much more dependable. And when you're using your Verizon phone or using your Sprint phone, you want to have access to your network, and that brings the network closer to the user again. So you can do calling over Wi-Fi. It's not always dependable. Many people I know who use it, I've used it myself. I don't find it particularly useful. But companies that make the switch to a RAN application typically find much more success.
Why isn't it very useful? I've actually experienced that myself.
It's just the way the radio frequency propagates. There's ways that you could build up that portion of your own home network to help it improve. But I'll take myself for an example. I live in a 1921 bungalow, which is not really RF friendly. I've got chicken wire and plaster in the walls, so that doesn't really make for a friendly RF environment. Now, some newer buildings, you'll find that you may have better coverage, but again, RAN signal source is the way to go.
Now, also, let's talk about utility infrastructure solutions. I see you offer aerial services. What is that?
So you've seen guys in a bucket truck before. You've seen guys with the proper safety equipment. You see guys blocking a lane of traffic. So the aerial services that we provide are stranding fiber or coax, lashing that fiber or coax to the existing infrastructure, or placing small cells on the top of wood poles. So we do a lot of aerial type work related to that. Now, aerial could also mean tower climbers, and we have tower climbers that climb 200-foot towers to replace equipment. It's not for the faint of heart.
Yeah, where do you find these people? I mean, I think we've all seen the videos, and certainly even the 1,000-foot towers.
They come from a wide variety of places, and there's folks that love to climb, like to rock climb, and I've met quite a few guys that just as a sport enjoyed rock climbing and said, okay, well, maybe I can make a living at this, climbing towers. But there's also other technicians that have a greater interest solely in the technology and climb.
Underground services. That's one that interests me, because obviously we're so close to New York City, and we saw what happened with the hurricanes. And we just, New York City, as a prime example, is that infrastructure, almost all of its infrastructure is in need of replacement.
Yeah.
So what are some of the challenges you find with that?
So the challenges are there, right? I mean, there's a lot of work that we do that is underground in the right-of-way. We do a lot of boring, a lot of trenching for some of our MSO clients, and even fiber to the cell, fiber to the facility that requires some form of digging or boring. So there's obviously the first challenge of making sure that you're familiar with the geography you're working in to understand what's pre-existing. You work with your local utilities to make sure that you're coordinating appropriately so that you're not hitting any power lines or any gas lines, which, if you watch the news, there have been incidents around the country. Fortunately for SQUAN, we haven't had those because we do prepare. And you need to prepare whenever you're dealing in that environment. There's a lot of risk when you're working in the public right-of-way, and making sure you're aware of all the environmental issues.
So now, primarily, it's fiber. What do you see as being the next technology?
So I think this one is going to take us quite a long ways. I think if you look at the way users focused on their mobile devices and getting full streaming video to their phones, what we're going to find is that we're going to see video everywhere. Video on street signs, video on kiosks that are in the sidewalk, which are somewhere around New York City today. We're going to see a lot more demand for greater bandwidth to support that type of infrastructure. And I think ultimately, when you start to look at transportation and you look at autonomously driving vehicles, including your own car today or your transportation system for deliveries, you're going to find that all of those in some form or fashion will be connected to the network.
The autonomous driving vehicles is really surprising because obviously it's a wireless system, but that has to go back to a ground-based system. How do you ensure that the ground-based system is going to be operating?
So at the end of the day, all of the networks we build, the wireless networks, are tied to a wireline system. It's really just bringing fiber to the cell site to act as a coverage mechanism to make sure that you have appropriate coverage. So it's really no different. And what will happen is you'll start to see nodes pop up along the sides of highways, along the K-rails, along the shoulders. You'll start to see more and more sensors emerge that will act as transceivers to deal with that type of traffic. Not just road traffic, but signal traffic.
So talk to me about SQUAN's acquisitions and how it's grown.
So when SQUAN was originally purchased, SQUAN Construction was purchased, we looked out at the horizon and saw that smart cities was going to be a big initiative across the entire country. And what we decided to do is take a look at those services that were arm's length and take a look at how we blend some of those services into the core of SQUAN's existing services base. And we looked at fiber, we looked at fiber design, and we looked at additional construction support to blend that all together. So if you look out on the horizon at smart cities, we took a look at where we are today, acquired companies that complement what SQUAN does today, and with a view on eventually looking at smart cities as an end target.
Are there any companies out there that you're looking at now to acquire?
So we're always looking at companies. So as we're owned by RFE Investment Partners, and what we do is we look at a number of different companies routinely to see what complements our existing SQUAN structure. So that could be a service vertical, it could be a geography, it could be personnel that have a certain skill set that we bring into the fold. But yes, we're still looking at acquisitions.
Keith, thank you so much for being on Spotlight.
Thank you, Jason.